Okay, and we're back, and we are going to do the final part of this project where we make some visualizations using our data sets and hopefully looking at our data in different graph form might allow us to come to some conclusions that we might not have come to if we were just looking at this table. We might also be able to see some correlations between different parts of the data, for example, like calories versus serving size or something along those lines. So that's what we're going to look at. Now, because this is more of a shorter project, we're not going to go into all the different graphs that we can actually make in Pyret, but just so you know, there's a couple different types of graphs. So we could do things like pie charts. We can do things like bar charts. We can do histograms. We can also do scatter plots. We can do some linear regression, which is like your line of best fits. Linear regression. And there's a couple other ones, but the one we're actually going to focus on in this tutorial is the scatter plot. And the great thing about the scatter plot is that scatter plots allow you to see correlations, or if one particular part of our data has some sort of relation to another part of our data. And that's what makes scatter plots great. So scatter plots let us see correlation. Now, one thing I will note though, and this is really important, is that correlation, and you might have heard this statement before, correlation does not necessarily, that's not how you spell it, does not necessarily mean causation. And what I mean by that is just because you might notice there is some trend that you're seeing in your data, it does not necessarily prove that those two things are related. Okay, they might be related, they might not be. So just be careful about that. Just because you see a correlation between something does not necessarily mean that it's actually there. So let's start off by creating a data visualization. So all of these different graphs, the code for these graphs you can find in the Pyret contracts document, and that is linked in the video. And that will show you, actually, it'll give you an example code, and it will also show you like the parameters that go into the function and how it works. And also those graphs are located in this image library. So that's why we included images, was to be able to create these graphs. So let's start off by making a scatter plot, and I'm actually going to do it on the right side over here. So I'm going to hit run to get rid of that big table. And we're going to make a scatter plot over here. So scatter dash plot. And this function takes in a couple different parameters. The first parameter it is going to take is the name of the table that we're pulling the data from. So we're going to use our new table, so drinks dash table 2. It's then going to take in what item do you actually want to graph. And so let's actually graph, let's do this. Let's look at our original spreadsheet, and let's graph, I tell you what, let's do type of beverage. That'll be the actual plot on our graph. So it's called type. And then we need 2 strings, and the strings are going to represent the x-axis and the y-axis. And because this is a scatter plot, X and Y-axis have to be numerical values. You can't use true or false because it's very hard to plot a word on a actual graph. So we need numerical values. So let's see. So if we were looking at juice, maybe we could see if there is a correlation between calories and sugar. So let's just do calories maybe on the x-axis and sugars in grams on the y-axis. But I'm going to come up here and make sure I have my column names correct. So we'll do calories with a capital C, calories, and we will do sugars in grams, sugars underscore G. And let's hit enter. All right, so you can see here we've got this graph, and calories are on the x-axis, sugars are on the y, and these dots represent the type of beverage. So as we can see here, it looks like the majority of our data is clumped right here, and it seems to have a linear relationship. So what that means is, as the calories increase, so do the sugars, and it looks to be almost directly related to calories, right? So however many calories they have probably have the same number of sugars or very close. You'll also notice we have some up here, which is really strange. That is a coffee drink. As you can see there, we've got some milk up here. We also have drinks that are very high in calories, but very low in sugar, which is interesting. And up here we have some drinks that are pretty high in sugar and actually not super high in calories, but the majority of our beverages are down here. So what this scatter plot does is that it lets us see connections between things. So maybe let's switch this up a little bit and let's take a look and see if there's any relationship between calories and caffeine. And how is caffeine written? I'm just going to copy it right from there. Let's take a look, hit enter. And it does not like that because I missed the G. Oops. Put in a G there, there we go. Huh, very weird. Okay, so we've got caffeine, we got calories. Interesting. So it looks like, so there doesn't seem to be a huge connection really between caffeine and calories. So it looks like the majority of our beverages have very little caffeine and like really range in calories. There are a few that are very low in calories, but also very high in caffeine. Looks like your coffee drinks up here. So pretty low in calories, but also high in caffeine. Then we've got soda down here. I'm guessing that might be diet soda with zero calories, but still has some caffeine. Interesting, but yeah, it looks like a lot of your juices, your milks are down here, so very low in caffeine if they have caffeine at all, but also high in calories. Interesting. So that's what's kind of cool about the scatter plot graph. But what we're going to actually do is we are actually going to create another function, and here's why we're going to do that. Because if you notice, this scatter plot is great, but I think it could be more clear. And the reason it can be more clear is that we are graphing type of beverage, and you will notice that all of these beverages are kind of mixed in and they all have one color. I think what could be really helpful is if we gave each type of beverage a different color circle. And I think that would be pretty helpful. So here's what we're going to do. I'm going to come back up to our function section. And we're going to make a function that gives a color circle to each type of beverage. Now, before I do that, I'm actually going to open up my table. We'll use our new table, drinks-table2.order-by, and I'm going to order it by type. So this is another function. The dot order by, and what that does is it just sorts your table by a specific column, and it takes two parameters, a string, which is the column that you want to order it by, and it takes a Boolean, and the Boolean does one of two things. If it's true, it'll order the table ascending, so that's from smallest value to biggest, or A to Z, or if you did false, it would be descending, so largest value to smallest, or Z to A. So we're going to do this alphabetically, A to Z, and I'm going to hit enter. And you'll see we got type here. So the reason I'm doing this, I just want to see the columns that we have, and I'm just going to make a note of them. So I know we've got coffee. What else do we have in this table? We have energy drink, and I'm going to copy that just to make sure I do not make any spelling errors. Because remember, Pyret is not smart. Well, no programming language is smart. It does not know what you mean if you misspell something or use a lowercase. It's not that smart. Lots of juice. We've got milk. What else do we have? Let's see. Milk, milk, milk. We've got other. That is interesting. I wonder what is in other. Oh, okay. Interesting. Other, we've got soda. We got soda. We have tea. We have water. And that looks like it. So it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8 different categories. So here's what we're gonna do. And we're gonna make a function. So I'm gonna type in fun. And I'm gonna call this function color-type, because I'm gonna be giving a color to a specific type of beverage. And of course, just like all of our other functions, we take in a row for this. And this one's gonna be a little different. And the reason this is gonna be a little different is because we are gonna use something or a concept known as selection. And what selection is in computer science, and we'll learn about this more as we go throughout the year. But what selection is selection is your if, then else statements. So what this is doing is it allows your program to make decisions almost. So if one condition is met, then your program is going to do one thing. If that condition is not true, your program is going to do something else. And then if none of those conditions are true, your program will of course do something else. And we'll see how this works. But basically, I use the keyword if, and what I do is I say if, and I take my row and I take my brackets, and I want to look in the type column, because that's what this function is going to do. It's going to give a colored circle to a specific type of beverage. So I'm going to look in a row, I'm going to look at this column type, and I'm going to say, well, first off, if that value is equal to coffee, because remember, what's in the type column are strings because they're inside quotation marks. So I want to say if this row equals coffee, I put a colon there, and the colon basically means then. So if this statement here is true, then I want to create a circle with a specific color. So here's the function for a circle. And again, you can find this code inside the Pyret's contract table or Pyret's contract document, but the function is called circle. And again, this is also in the image library that we imported. The function circle takes in 3 parameters. The first parameter is the size of the circle in pixels. I want it to be 5 pixels. That's about the size of one of these circles here on the scatter plot. So it's going to be a size 5. I want my circle to be solid or filled in, so I type in a string solid. And the third parameter is another string, and it's color. I'm going to choose brown. Now, I actually don't know if brown is a built-in color. I'll have to run the code and see if it works. I'm assuming there's a color called brown. We'll see. But I made it brown because it's, coffee. So that's brown. Cool. Okay, so what this function does, well, it checks to see if a row meets this condition. Now, if the row does not meet this condition, if it is not coffee in that row, this statement is false. And so it moves on to the next line, which is an else if statement. And we're basically going to do the exact same thing, except instead of coffee, we are going to do energy drink. Energy drink. And let's make this purple. We'll make that purple. Cool. Actually going to highlight this whole thing. Now again, if it's not coffee and it's not an energy drink, let's go down and check again and see what it is. Let's say it's not an energy drink. Let's see if it is juice. If it's juice, let's make an orange circle. I'm going to do orange. Seems like a lot of juice is orange. I don't know. I could be wrong there. And if it's not juice, let's see if it is milk. What color to do for milk? You would think I should do a white circle. I actually don't know the code. I would like to do like an outline that's black with a white interior, but I don't actually know the code for that, and I'm not gonna check right now. So let's make milk green. So milk will be green. Milk's green. If it's not milk, now I'm gonna leave the other for a second. I'm gonna come back to that. So I'm gonna go with soda, and I'm gonna go with red, just because I'm thinking like a red Coca-Cola can. That might stand out to me. And after soda, we got tea. Darn, what color should tea be? Let's, kind of wish I had made tea green. Maybe I'm gonna make tea green. Let's make milk. Darn, what could we make? What color could we make milk? Let's make milk yellow. Don't drink yellow milk. That sounds really bad. We got milk, tea, water. I was saving water. I think we'll make water blue. Let's make water blue. Okay, and this is why I saved other. So if it's not coffee, okay, and that's false, it checks to see, is it an energy drink? Well, if it's not an energy drink, is it juice? Nope, not juice. Okay, that's false. Is it milk? Nope, that's false. Is it soda? Nope, that's false. Tea, water? Nope, nope, nope. None of the above. If it's none of the above, it's gonna be other. It's gotta be other. That's the only other option. So we'll make a circle, and I'll make the circle black. That will cover all of our other beverages. And that's how if statements work. So what it does is it allows us to make different selections within our code, and it will assign the correct thing that we want to assign to that value. So in this case, it's circles, and it should work out pretty nicely. So the last thing we do to finish this off is we type in the word end, and what end's gonna do is it's gonna end our if statement. So that tells Pyret we are closing out this if then else chain. And then we type end one last time, and that tells Pyret this is our full function. Okay, so let's hit run, and I'm just gonna see if we get any errors. It is possible that we might get some errors here. We did not get errors. Okay, so just to test out our function, I'm gonna use some of my predefined rows. So let's run color-type. And first let's put in juice row. Juice-row. No, juice underscore row. Now, what should come out when I hit enter? Well, it's juice. And juice should have an orange circle. So when I hit enter, yep, I get an orange circle. Let's test this out with our milk row. We should get a yellow circle. Okay, that looks like our function works. Now, here is a really cool graph that Pyret lets us do. This graph is called an image scatter plot. And what it does is it's very similar to the regular scatter plot, except it uses a function to create images that are actually the plots that we're gonna put on our graph. And so what it's gonna do is, instead of putting on just your standard sort of blue plots, depending on the type of, the type of beverage, it's going to give us a different color circle. So let me just show this to you real quick. So first, let's look at the original scatter plot. And the original scatter plot, it took in a new table, drinks-table 2. It took in type. That was what we plotted. It took in calories on the x-axis. And it took in, I think, sugar in grams on the y. No such column. Let's see. I must have spelled something wrong. Sugars, not sugar. Okay, so here was our scatter plot, right? let's see what happens when we do an image scatter plot. So the image scatter plot is going to work in much the same way, except it's image dash scatter plot. And it's going to take in a table. And then instead of the type, it just takes in what you want on the x-axis, what you want on the y-axis, and then it takes in a function. And you probably guessed it, the function we're going to use is called color-type. Color-type. Let's see what we got. Okay, so now we have a graph which is almost identical to our other scatter plot, except now we are starting to see a little bit of difference because now we can actually see the different types of beverages. So if you remember, orange is our beverages, or sorry, our juice. Yellow is milks. We got a lot of others in here. Milks there. We've got coffee out here. It looks like, though, a lot of these are kind of covered up. So it looks like our sodas are down here. I see a soda back here. It looks like we've got some water, which is really interesting that we've got both calories and sugar in water. I don't know how that works. It looks like we've also got some diet soda right here, probably 0 and 0. Green is tea. So we've got some tea that comes in, it's got almost no sugar, but very high in calories, which is odd. And then a lot of the milks are right in this kind of range here. So kind of interesting. And again, we can actually go back and we could, if we wanted to, filter out everything but soda and see how soda graphs in this way. There's a lot of different things we can do at this point. But the good thing is that we have a little bit of a background now in how Pyret works. And once you start to get the hang of it, it actually allows you to really start thinking about answering your own questions that you might have about your data, because now you have the tools to be able to figure those things out. And now I think what I'd like to do is maybe see if we can use our new table that has this column in it. So if I just type in drinks-table2 again, let's take a look. We got calories per 12 fluid ounces. Yep. Let's see. What could we graph? So I still think I want to do type, but I think what I want to do, instead of calories on the x-axis, let's do these calories here, because that might even the playing field a little bit and make it a little more accurate. And then maybe let's look at, I guess we can still look at sugars. Although I guess sugars would also still be based on this value here. So we might also, before we really do a lot of different things, we might need to also convert sugar per 12 fluid ounces also. But just for the sake of it, let's give that a shot and see. And let's take a look at what happens. So I'm going to pull up image scatter plot. I'm going to copy this to make sure I don't spell it wrong. Copy, we're going to do calories per 12 fluid ounces, sugars in grams. All right, so that looks a little different there. Now, again, this could be skewed, and it probably is, because we do need to convert sugar also to make it match with that 12 fluid ounces. Because if you look here, our calories are based on 12 fluid ounces, but sugars are not. So that could very much throw off our data. But honestly, it still looks kind of similar, although it looks like what this tells me here is that juice probably has a lot of sugar in it. And I think we probably know that. But when we went to 12 fluid ounces, this got pushed way back in saying that there's actually, okay, it's got less calories, but it has a lot of sugar. We start now to see some more sodas on the calorie line. So lower in sugar, but also high in calories. Still a lot of juice. Juice seems to be the one that has a lot of sugar in it. And also this coffee. I'd be very interested to know what this coffee is. So let's say, for example, you know what? What coffee is this, right? That's interesting. So if you look here, if I click on the dot, on the x-axis, it's saying the value is 5,520. So that would be calories. So if I come over here, back to my table, I'm gonna do a drinks table. See if I have an order by. There's an order by. We're gonna order this by, and I just copied it, so calories per 12 fluid ounces. We're gonna do this false because I want the highest value up top. Hit enter. I mean, it honestly should be coffee. Yep, this is the value right here. 5,520 calories per fluid ounce, but here's what I'm guessing. So see, this is instant mocha. And that tells me, if we look at grams, 13 grams. What this tells me is that because it's saying 13 grams, this is probably a scoop of coffee that you would put into a much larger glass of water or milk or something. So if you took 12 fluid ounces of straight instant cafe mocha sweetened, that's a lot of calories. Yeah, I don't recommend that. But as you can see, you start to see some interesting patterns once you really get looking at the data, and the visualizations really help you to do that. So I encourage you to explore this a little more and possibly look at some of these other graphs and see if there's anything else that will help you tell the story of this data. So a key thing to remember is that data cannot tell its own story. It's just a bunch of numbers in a table. You are the one that has to tell its story. And with that comes a great deal of power. You can make the data do what you want it to, and you can give false claims about that data, or you can be very responsible with your data and honest with it and tell a more accurate story. So it really comes down to how you interpret the data and what questions you would like to answer. But hopefully you followed along with me and did all of this, wrote all this code here, and that you have something very similar to mine. But in these videos, what we ended up doing is we looked at importing libraries. We looked at loading a spreadsheet into Pyret. We looked at creating a data table in Pyret. We also looked at saving different values to variables. We looked at creating some functions. We looked at data types. If you remember, strings, numbers, and Booleans. We also looked at if-then-else statements, and we looked at a couple different graphs. So hopefully that was helpful to you and you have created something like mine. The last thing I would encourage you to do, the very last thing, is to use your data to make a claim. Use your data to make a claim. And what I mean by that is something along the lines of this. So if I open this up, I would say, well, given the large number of beverages available to consumers, the majority of beverages that have the highest amount of sugar in them are most likely juice. And that is clearly seen by looking at the correlation between all the other beverages that we have, different types of beverages, and how many sugars and calories they have in them. So that would be just a sort of basic claim that I could make, and I could use my data and specifically my graph to back that claim up. So I encourage you to use your data to make a claim and defend that claim using evidence from your data table and your graph or graphs. Otherwise, that brings us to the end of this video. I hope you enjoyed the project, and we'll see you next time.